Welcome to SCiLS Lab tutorial number 7. Today we'll talk about quantitation. Quantitation is a very useful tool. Often after data acquisition, a lot of times people want to ask, where is my drug? Where is the metabolites and how much is it? So today I want to show you how to perform absolute quantitation for multi-imaging data, and how to construct a calibration curve converts mass spec imaging data into absolute quantities. So this is a little background for today's data sets. So clouticone is a pesticide used in French West Indies for several decades that affects human health. So today's goal is to detect clouticone hydrate with multi-mass spec imaging and quantify the accumulation concentration in liver. So we have a mouse model that have been exposed to clouticone 5 mg per kilograms body weight for up to 25 days. And we have 3 tissues at different day points. And we also have a control section. On there, we spot a different amount of clouticone calibrating, and from 1 to 20 picomole per spot to create a calibration standard curve. To get absolute quantity, we use a DCTB matrix including the C13 labeled clouticone. So now let's take a look at the data and how to perform quantitation. So after the data has been successfully imported into the SCiLS lab, the data layout should look like this. Okay, we can go over the regions since there are a lot of regions in this data set. Okay, on the very left, we have 3 dosed tissues. Okay, dosed 1, 2, 3 with different days of dosage. We want to find out the absolute concentration of these clouticone. On the right, these are individual standard spot with different concentration was spotted at a counterclockwise to create a standard curve. Okay, and the concentration varies from 0 here to 20 picomole per spot. Each spot is 0.2 microliter of the standard. Okay, so how to perform a standard curve? So first, we need to find out the ions of your interest. Okay, so we know the clouticone hydrate ion masses. We can just directly type it in. So 5 or 6.68. Click enter. All right. Then we can save the list here. This is the ion for the clouticone hydrate. We can put in another one. It's 516.71. Okay, so this is the second one. This is the ion for the C13 clouticone hydrate. Okay, to add a little bit more information, we can save the list here. We can say 2 ions. Then we can go to File, Pick List Table, and then we can find the 2 ions here. Okay, we can put in the name so that we won't make mistake. Okay, so this is clouticone hydrate. Okay, the second one is C13 clouticone hydrate. We can add this list to here. Okay, so we can add the name here, a notation column with the name. It will show up here. Now with the description names, we won't make mistakes. Okay, so next we need to perform a normalization. So remember 51671, which is the C13 labeled clouticone. we uniformly code it with DCTB matrix together over the whole tissue. So every pixel should constant concentration of this C13 ion, right? So we normalized every pixel spectra with this ion, okay? So we go to the normalization pan, okay? We choose, since we click on this ion, so the ion is already picked here. If you click another ion, see, they automatically picked up. So we need to do a normalization against this peak. We'll use the peak area, and then we can do total ion count. Since this is a multi-TOF data, okay, we can save the peak normalization here. Automatically name its 516, simply one peak area as normalization. Pretty quick, take less than a second. Okay, so as you can see, 51671 is uniformly coded. We already normalized it. And now when you click on 506, immediately we can notice the various concentration with different brightness. So for example, we have 0 with the lowest until 20 is the highest. Yeah, we talk about this in the regions pan. Okay, so now after normalization of individual peaks, we can perform the calculation of our dosed tissue. What's the absolute quantity? So go to File, Quantitation. Okay, so we know the ion we're interested in is 506, and the normalization we want to use is the peak area 516 we just performed. Okay, there are different regression mode. So this is a by default standard linear regression. That's the one I normally use. If you are interested in more aggressive, more complicated settings, you can choose the other two. You can check the manuals. So now we can start a quantitation. And here, if you know the units of the concentration, you can put it there. Since we put picomole per spot, and then after the calculation, I know what I'm getting for the unit, so I can put it in. Okay. Here we can type in the amount of the standard that we put on the control tissue to create the standard curve. Here we have 0, 1, 2, 4, 8, 15, and 20. You may already noticed while typing in the standard curve is immediately showing up. Okay, we can see this is a pretty nice coefficient of determination. The R-square is 0.99. Okay, and we have this pretty nice linear correlation for this standard curve. Okay, and you may notice we can read out the dosed concentration here. So this is the mean concentration, and this picomole per spot. Okay, because we put it in 0 to 20 picomole per spot, and this is the calculated concentration. Okay, this is the actual concentration after the curve, and these are the calculated concentration. Okay, we also notice that arrows of the standard curve is calculated in percentage. You can also notice the error bar on the standard curve in the plot. At the same time, in this summary, okay, it shows you what's the parameter you have used, okay, what's the algorithm you have used, and what's the limit of length, and what's the limit of detection. Okay, and you can do a screenshot of the table by using this button, save a high resolution image for presentations. You can also export the tables or the graph or summary into the clipboard. Okay? I think that's all for today. I showed you how to perform a calibration and how to find out absolute quantity. Thank you for watching.